My name is Elijah Meeks. I'm down at Stanford University. I work in the library. I do support for something called Digital Humanities Scholarship. And today I'm going to give a talk on integrating narrative text and computational models and information visualization. And originally, the title of this talk was Integrating Text and Information Visualization and Models. And then I found out that models mean a lot of different things to a lot of different people, especially when you talk about MVC. And text means a lot of different things to a lot of different people. So I had to make this really cumbersome, really long title. But I come from academia, so that should be OK. If you want to see some of the work I've done, I maintained for a while a blog, dhs.stanford.edu. So I work in the digital humanities, which requires some definition. There's kind of a cottage industry of defining digital humanities among people who do digital humanities. And my going definition was bringing computational techniques like GIS or GI science, natural language processing, network analysis to traditional humanities research questions. So using spatial analysis to look at literature, or using network analysis to look at the social structures of Roman political systems. I think another great way to define it is through examples. So some of the examples of the work we've done at Stanford are at orbis.stanford.edu and kindred.stanford.edu and citynature.stanford.edu. There's also another site, digitalhumanities.stanford.edu, that gives sort of a project portfolio of the various types of work done in this area at Stanford. But what I found over the last year or two is that my definition kind of changed. And it became just using D3 to help address traditional humanities research questions. A lot of the work that I did when I started at Stanford about 4 years ago involved ArcGIS or network analysis toolkits or natural language processing toolkits. And more we saw the uptake of using information visualization, web accessible information visualization that's key to interactivity, and specifically the D3 library, so that it seemed like I became the D3 guy. We'll just use D3 for this. Was put in place of we'll just use ArcGIS for this or whatever. But there's actually a real good reason for this. Two reasons. One, along with those other sort of pillars of computational analysis, what I found that I was doing a lot more of was this broader concept of information visualization. So I was using information visualization to address traditional humanities research questions. And I was doing that because we'd moved away from just working on the analysis and research end of things and started to work more and more on publishing this work, trying to get it out there in a way so that it wasn't just the results of the scholarship that people got access to in a traditional scholarly monograph or journal article, but rather the actual computational models or the approaches that were being used. And that required information visualization, required interactive information visualization, and it also required some principles that I'm going to go over in this talk. So an example that I'll go into in a bit more detail in this talk is Kindred Britain, a work that we published in November of last year. And Kindred Britain is what we're calling an interactive scholarly work. It deals with British culture, and it deals specifically with genealogy in British culture. So it's a network of 30,000 British cultural elites and their relatives, such that everyone in the network could be connected to everyone else in the network by a connection of marriage or lineage. It uses D3.js entirely on the front end. And it has a PostGIS backend because PostGIS allows us to do some of the cool spatial stuff and also some of the cool network stuff. And so it looks like an information visualization project. There's a network view. There's a timeline. There's a map view. If we go and sort of look at the interactivity, and this is what you would see at kindred.stanford.edu. So you have this interactivity between various British cultural elites like Joseph Priestley and Mary Shelley. So we could go over and interact with this model of British culture and look at how Joseph Priestley was related to Mary Shelley. And we could see the the locations that they had in common based on where the events in their lives took place. So if somebody was born in a certain place or employed at a certain place, they got married at a certain place, then those events that tie them together also in some cases have locations. So we can brush between them and we can see in these various views the different ways that they're connected. So France is highlighted because we have one individual here who is somehow connected to France. There's another aspect to Kindred Britain that I think is the real innovative aspect. I mean, I'm very proud of the technical pieces behind this. But there's a view in Kindred Britain that we refer to as stories. And stories were linear narrative text scholarship about this phenomena of British genealogy and how it related to British culture. And the stories have, along with all of the features that we've already seen, right, this view into a model on the right that takes different perspectives, it has this linear text that somehow explains how something being shown in the model relates to some cultural or methodological aspect of the research that we did. And the way that it works is that it loads a different view of the model with each part of the text. And then as you look at these highlighted sections, when you click on them, it shows a different reformulation of that view into the model, which I'll get into at the end of the talk. But this is fundamentally the idea of integrating model and information visualization and text. This isn't new, of course. We've seen graphics and text and model integrated before, especially in academia. We've got papers where there's a model here, there's some text here, and there's some kind of graphic here. And you might not spot the model or the system, but it's expressed in this mathematical notation, deals with concepts of structure and emergence and causality. The text deals with narrative and dialogue, either with other scholars or with the reader, and decisions on what to emphasize. And then the graphics, of course, for this audience, I'm going to gloss over the graphical aspect because we know graphics deal with expressing quantitative, categorical, topological, and other forms of information using visual methods. We also see this out in more popular press. So this is The Economist. And The Economist has some text if you go to an article on The Economist, and it has some graphics. And then if you look at the bottom, The Economist has this wonderful and to many people incomprehensible but still clickable little information visualization thing here. Does anybody know what this does? Does anybody know what it means? This China is somehow connected with a line to India and Vietnam and Asia and Iran, and it's all in a bubble. Right? Nobody ever knows what this means. It's, as far as I can tell, it's the tags with articles, and it's the creation of a co-citation network based on the tags within articles. So it's showing you actually sort of a model of the popular articles that are on The Economist and how they're related to each other based on shared topics. And so in a sense, what you're getting is you're getting a system that The Economist is a representation of, where these papers, these stories are related to each other. Maybe I'll stop yelling. Maybe I won't. These papers, maybe I'll really start yelling. So that these stories are related to each other in some formal described process that can be exposed to the user. And I think that that's in contrast to what we typically think of with information visualization, because information visualization we typically think of as being a black box within the DOM, even if it's D3.js, so it's using traditional DOM elements, but a black box that isn't aware of and does not somehow relate to what's going on in the linear text, which is its own black box in comparison to the information visualization. And the model itself only shows up. The system that you're sort of taking part in when you make a tweet or you go buy something on Amazon only shows up as an effect that suggests things to you. So you don't actually have any interaction on Amazon with the recommendation model that says maybe you want to buy this thing now that you've looked at that thing. And I really think that users want that I think that it's a challenge, but to present that, and especially tying that to information visualization, would provide a more useful experience, a more enjoyable experience. I think I get into one of these questions a little bit later, or maybe not. But so I'll touch on it now, and then if it's on another slide, I'll just let it go. But you don't give people the ability to perturb their own, the system that they're actually taking part in. So we think of Twitter especially. If anybody's played with network analysis, it's so easy to download your graph for Facebook or Twitter. But it's easy for someone who's a developer, who understands it, who follows some rules. Why isn't that exposed to a user so that they can then see how their own network might change were they to make decisions based on how that network actually exists as a sort of formal expression of the social network that they're embedded in? So graphics take all sorts of forms and typically deal with this concept of channels. So there are different channels for expressing information, some of them particularly well suited to different categorical types of information. And text, when it shows up in InfoVis, is often a graphic and not actually text in the sense of narrative text. So these word clouds down here that are being used to express the results of topic modeling, which is a natural language processing approach to identify themes, common shared themes in documents, is using text, but it's not using text in the sense of a linear narrative. And I think one of the reasons for that is that most of the folks who are working in InfoVis, most of them, not all of them, don't really realize how complex text can be. And here I mean texts, linear narratives. That if we look at examples from history, and especially these medieval manuscripts, you see that people they have a linear narrative, and then they have lots of dense annotation, and they'll have information visualization in there, and they'll use color, and they'll use graphics, and it's all tied together to tell some kind of story, not just to one audience, but to multiple audiences. The reason why you have illuminated manuscripts is so that audiences who might not be literate in the text can still follow along with the message. Well, that's not one of the reasons, but one of the benefits of an illuminated manuscript is that different audiences can have access to the knowledge or information that's being passed along in there. And when you deal with a more complex medieval manuscript, as we do, one of the units at Stanford University deals with a complex annotation system for medieval manuscripts. You realize just how complex text can be. So this is a single manuscript. It has graphics embedded in it that indicate some kind of relationship to the text. It has a lot of text. It can be folded in different ways. So the reader approaches the information in different views into the model of the system being represented here. And I think if we take that as our sort of concept of what linear text can be, what narrative can be, instead of this sort of antiseptic Helvetica on significant white space with proper padding, which is what which is the caricature of what designers think of as the best form of text, I think we can actually advance the field. We can push things forward, especially when you look at things like the terrible mistakes that people are making that Tufte would get so angry about, right? Using multiple colors for the letters in your title and putting it on a curve. Putting text on a curve is something that went out in like 1999, right after people found out you could do it with SVG. And the model, and maybe model's a bad word for it, maybe the word is system. But the model, this thing that lives underneath it, this formal expression of how your data relates to itself, is something that I think we need to embrace more. We need to deal with more specifically, and here's my example that I realized was on the later slide, right? The capacity that users could ask questions of their Twitter network, like what happens if I dropped all the people I follow who are over the age of 40, right? This is access to that model. They have a network, and they could see the structure, and they could see how that structure changed if they interacted with it formally, instead of interacting only with the sort of output of the model as we deal with it. And I think what this relies on is a concept of systems that doesn't deal with, and this is why I'm a little bit leery now of using the word models, doesn't deal with computational models from science, but rather systems as they're expressed in games. So on the bottom here, it doesn't show up quite so well because it's a dark slide, is the C model that we used in Orbis, which is a transportation network model of the Roman world circa 3rd century AD. And above it is Dwarf Fortress, which is, one person knows, it's a sort of beloved game to a small and rabid community on the internet. But most of these complex games that have systems that somehow formally express how societies interact. Now, societies that you're trying to leverage to go stomp other societies through warfare, most typically. Dwarf Fortress is interesting in that it has several different systems that you don't think of as showing up in a game, such as a system for creating a geography and making the rivers run correctly and building cities and building this all sort of on the fly with every new world that you create. And then having these little drunken alcoholics, your dwarves, interact with each other with relatively complex personality models. And so what I'm suggesting is this idea that we go back to gamification and we gamify things more. But instead of gamifying things where our inspiration is a game like Jewel Quest, our inspiration instead are games that are complex systems where people get to interact with this complex system. And by interacting with it, better understand it. And this is a sort of, it's a broad call that I can show a few examples for. I don't have a recipe that I'll be able to give you at the end of all of this. But I can point to some of the work that we've done that tries to deal with this. So one example is to leverage the capacity for these statistical measures to take unstructured data like text and to create from it structure. So if you have all of the tweets from all of your users or all of the comments on your website, you can use NLP. There's a lot of natural language processing techniques that from that can derive similar themes, keywords that people are using, and tie them together. And create a dashboard. We deal with dashboards, but dashboards still tend to deal with flat data sets and give you different views on flat data sets. But instead try to foreground this idea of dealing with a model, even when you're dealing with the flat data set that's the end result of it, that you know that it came from this system, and trying to focus more on the rules of the system rather than the output of that system. If we tie that to text, if we tie that to linear text, then we can get toward this idea of data-driven documents, where you have linear text that is accreting as linear text does, and while it's accreting, as in the case of the Russia left behind, so is the path from some part of Russia to some other part of Russia that ties into the text. How to Fold a Julia Fractal is this great interactive document that at points allows you to interact with a model of this mathematical principle that they're exploring. So one of the systems that we've been building is this thing called Orbis. Orbis has been called the Google Maps of the Roman Empire because you can find out how long it took to go from Constantinople to Rome. We'll find someplace more interesting than Isthmia, which only everybody knows where Constantinople and Rome is. And so there's a transportation network model underneath. And the transportation network model allows you to ask questions like, how long does it take to get from Rome to Constantinople in September by ox cart? And how much does it cost? And is it a different path if I'm interested not in speed but in expense? The interesting thing here is that once you have this model that you build these methods for displaying, using information visualization to express it, then you actually find other affordances. So if I know how long it took to get to Rome from Constantinople, then why not tell me, well, how long does it take to get from Constantinople to everywhere else in the Roman world? And right, we can use a dynamic distance cartogram to distort the Roman world and start to allow the user to explore this system, this representation of Roman history as a system, a very primitive and schematic system, a transportation network model that tells you where the empire is from some certain point. And then using that, maybe go further and divide the world between these two centers, right? And give other capacities to say, well, if this is my set of priorities, and here's the interesting thing here, if this is my set of priorities and this time of year, the cops don't want you to know about Orbis, then how does the Roman world fracture? And what's interesting is this isn't a single data set. If I change any of these settings over on the side, if I change my priority or the available modes or any of the factors in this system, then it will change the way that the world is split up, if I change the centers that I choose. And we've been calling this the sort of enabling the user drive. The initial version of Orbis did a few of these things in a very constrained way, and now what we're trying to do is we're trying to expose all of it, so that people can explore it, not only so they can explore it to enjoy it, but so that they can explore it to critique it and amend it and cite it. Another smaller example is a piece of information visualization that I did with my wife for a picture book about the wolf OR7, the first wolf back in California. So for those of you who don't know, some wolf wandered into Oregon, and then wandered out of Oregon and into California and wandered around all of California. And you could actually, if you spent the time, like I did, you could find out its rough coordinates, and you could track its path. And you could find out where it was during particular parts of the year in 2012. And so this is a model of this. This is a system. It's a very simple system representing where this wolf was and what it may or may not have been interacting with. And what we realized was that now that it's this, and this is, by the way, this is D3. This is a satellite projection of D3. It just happens to use a watercolor map underneath it. So we can lay all sorts of interesting geospatial information on it. So images have key elements to them that are considered unstructured, that if you allow users to annotate them and point them at parts of the system, can be used to say, well, where are the bears in relation to where this wolf is going? Or, I think this is the one, I always forget. What are the ecoregions of the western United States that this animal is passing through? And again, it's a system. You've already declared that this is a geospatial view of this story. And if that's a geospatial view, then how does it tie into other aspects of this geospatial system? And I think what I want to highlight is this idea that linking the image, linking this bitmap image to some state in the model is the same as linking some snippet of narrative text to a state in the model, which I'm going to get into a little bit in more detail with the example after this. So another, I don't have anything that I can show off because this isn't public yet, but one of the things that we're doing down at Stanford now is we're working on the Çatalhöyük Living Archives. So Çatalhöyük is a site in Turkey. It's the longest continuously occupied human settlement. And it's also a 25-year archaeological dig. And so we're looking not only at a geospatial database that has hundreds of thousands of artifacts that have been discovered, and also the spatial areas of the areas that have, the spatial footprint of the areas that have been dug, but also all of the text that's come out of it, all of the co-authors and their relationships via group membership or co-authorship of papers, to see how knowledge production has occurred and changed over the 25 years. So it's simultaneously looking at the evolution of the site and the evolution of knowledge production. And we use some of the principles that we'll see when I get into Kindred Britain with the Living Archive, which should be, the demo version should be public, I think, in April. The main reason why I think we have to do this is because there are 500 million tweets a day. And no matter, somebody in this audience is going to tell me they can handle 500 million tweets, that they know the server architecture that can deal with it. I can't. And what I've found is that even dealing with, well, I did some Twitter analysis back when it was only 100 million tweets a day, and that seemed like a lot to me. But what's interesting is that Orbis, in comparison, is very small. If you look at the core database, there's a few tables that deal with 700 sites that have 1,900 routes. But if you take into account all of the permutations of the options available for exploring this model, and you were to download Orbis as a shapefile, it would have somewhere between 5 billion and 5 trillion entries. So anything can be made into a massive data set that you can't deal with. Whereas if you start to deal with the system, the sort of system as it changes, the model that is Twitter, then maybe we can get more purchase on it than if we keep trying to deal with billions and trillions of data sets. I think this is out of order. Or maybe it just replaced another slide. So what we've been finding, especially with Chadel-Hewitt, is an attempt to not only annotate the data on our end, but provide users the capacity to find states within the system and annotate the states of that system with text, with vernacular names, with labels, or with narratives. So you could imagine how the Fukushima Daiichi disaster and the tsunami were related. They were part of some larger system that if you were modeling it, certain parts of it would be described as being the tsunami, and certain parts of it would be described as being Fukushima. And the text that then is annotated to those states not only provides other users with more understanding of this system, but can also then be mined using natural language processing techniques to find out if there is a particular way of speaking about Fukushima and the tsunami that dealt with the tsunami more than the reactor, or otherwise feed into machine learning techniques so we can derive these without user input. So what I wanted to do is I wanted to look a little bit at this stories feature in Kindred Britain. And kind of dive in a little bit more as to how it functions. Because how it functions, if it functions, is part of this formal expression. And when we were building this, and this was built with Nick Jenkins, he was the PI on the project. He's a Stanford professor of English. And Scott Murray was the designer on this project. We knew that we wanted to address this issue of linear text, a narrative text that's related to the phenomena that are within this genealogical network. And the method that we ended up with was to create these multi-part text narratives. Each part of that text narrative opens up a different view on the model, a different query into the database, however you want to, whatever verbiage you want to use. Let's see if I can. There's my geography. I couldn't find my geography. And then each link, or some links, some annotated links within that text, then focused on particular views, particular reformulations of that view into the model. And that means that if we had enough of these, we could talk about whether or not there was a certain language that was tied to certain states in this model. If we had enough samples, we could begin to formulate this. We could use that same technique to then go to a text that wasn't made for Kindred Britain and try to derive from it claims about other British cultural practices that might relate to this particular view of British culture. So I thought that, that's not my next slide. Next buttons everywhere. So what does it look like? Well, every story is a JSON object. Every story, like I was saying, starts out with an initial function that sends a query to the database. And that we just wanted to do, primarily for technical reasons, you want to, the database query is more expensive than just reformulations of the view that's done on the front end. But each initial state is related to some particular chunk of text. And then within the chunk of text, there are individual functions that relate to modifications of that state. And I think tied all together, that when we start to, if this is a productive practice, it ties linear text into what we think of as information visualization. It does that using this concept of systems or models. And I think creates a richer experience than data visualization existing in one ghetto on your website and your linear text existing in another ghetto on your website, and the model existing somewhere as something that you use a batch query on to create the data for the data visualization. I think tying all that together can create richer, more true, data-driven documents than if we leave them as these separate entities. And that's it for me. So we have time for a few questions. So, yes, sir.
So you talked about gamification and sort of sophisticated gamification and tying these models into the text use. How do you encourage and or train users to engage with those interactions on a more than trivial level?
So here's what we found out with Orbis. Orbis was really successful. It was built for, the story was it was built for 35 people. The PI for Orbis, he's a classics professor, Walter Scheidel, and he said, I want to build this thing, and my audience is 35 people. I know who they all are, and I respect their opinion, and once we build this, we'll be able to do more Roman classic stuff. And he built it for that cartogram function. He wanted to see the distortion of the whole empire. But what we found was when we built that, you could also calculate routes from some place to another. It was just it was the affordance of the model. What we discovered was that people have been interacting with transportation network models in a quite sophisticated manner for more than a decade because of Google Maps and MapQuest and all of that. It's a rhetoric that people are familiar with. So I think the first step is to tie it to practices that are already in existence where you can see either metaphorical or direct literacy or fluency even, so that people, as soon as they saw some list like that, even if, even in the initial version, which was just a bunch of tabs and drop-down boxes, they said, oh, I know Google Maps. I can interact with this. And they didn't think they were interacting with a transportation network model, because that's not what Google Maps called it when they made it, or MapQuest, they didn't call it that either. But that's what they're doing. They're actually making relatively sophisticated queries into a transportation network model. So I think it's a matter of finding, what I look for, one of the areas that I think you see a lot of sophisticated interaction is with map-based strategy games. You see a huge amount. I mean, you look at these interfaces, they're full of buttons and icons and massive amounts of data. Some people call them spreadsheet games, right? Because that's all you're doing is pushing around information on a spreadsheet. I think that games, Google Maps, these kinds of things indicate that there are fluent user bases that you could then pull into more sophisticated usage. Yes, sir.
Would you expect there to be publishable results, or that these things themselves will be publishable new forms of knowledge, essentially?
So what we're working on is a linked data initiative that allows you to cite an API view into the model. So if we can give a Perl a permanent URL that points to a particular state of a model, then that becomes a citation that somebody could then integrate into either their own interactive scholarly work or a more sort of static traditional text. Right now, the works that have come out, the scholarship that's come out of Orbis has still been journal articles. And there are other initiatives, there are possibilities of publishers getting into the business of peer reviewing and publishing these kinds of things, but they require some capacity to not only cite the work as a whole, but cite some particular aspect of it in the same way that you can cite some particular page of a novel or of a monograph.
So really cool range of different projects you showed us. I'm wondering if, in the course of building these things, so building the Orbis network, you're building the Grid, have you started coming up with a library of tools that can allow someone to quickly say, I want to do Kindred Russia,
right.
I'm studying that here, and I want to do, every character in Charles Dickens novel rather than like how easy is it to build one that's the same just on a different data set?
So one of the reasons why we've had success is because we've avoided building tools. What you find with tools is that it becomes, you spend so much resources. We can do that, right? We can do that in the library because we don't have to have a business model. And so if you're not building it so that it's this robust tool that could be used in many cases, then you can sort of push the envelope. that said, there's talk around, especially with Orbis, because there's been a great deal of interest from various, a transportation network model of the Tang Dynasty or a transportation network model of maritime Venice, of investing in that and creating the necessary tools for that. I think that Kindred Britain is open source and available, but it's a mess. I wrote it, and I know it's a mess. And it also requires on the back end a pretty specific flavor of Postgres database with some, there's a lot of the network functions and everything that's not exactly a common stack. But I think the capacity is there. I think what we're going to see is it comes as a sort of second return to these projects where the investment is specifically oriented toward creating reusability. That's it. Thanks, guys. I appreciate it.